Hi, my name is Bruno Adorno. I'm a PhD candidate in remote sensing at Brazil's National Institute for Space Research. Now I'm gonna provide a very short lecture on fractional vegetation cover, to which you're very welcome. Uh, and so let's dive into remote sensing world, specifically for urban studies. First, I and my supervisor, Dr. Silvana Amaral, are researchers at the Laboratory for Investigation of Socio-Environmental Systems. And since my master degree, we have published studies concerning the methods on mapping urban vegetation and also how to integrate urban vegetation and also population data in order to measure urban inequities, specifically for cities in Brazil. And more recently, I was provided a scholarship by CAPES through the Institutional Program for Internationalization. I could meet Dr. Laurie Nesbitt at the University of British Columbia and networked with her and her lab students at Urban Nature's Lab to develop and enrich my research. So from now on, I, Silvana, and Laurie are working together on this topic. So as content for this lecture, we're going to understand what is fractional vegetation cover and why measure it. Also understand a little bit of concepts of remote sensing for urbanized areas, and more specifically, how it's useful for measuring vegetation. We're going to talk about this very well-known index called Normalized Difference Vegetation Index and how it's an input for fractional vegetation cover calculation. And finally, we will compare NDVI and fractional vegetation cover. So fractional vegetation cover, simply put, is, as the name says, the fraction of an area which is covered by vegetation. So it can range from 0 to 100%. This can be defined in remote sensing as the fraction of a pixel, which represents an area on land. This concept has been used in diverse disciplines like urban heat and also to understand and driving factors that influences the variation of fractional vegetation in urban areas. Also, it's important to notice that for being an easy index to calculate, it's possible to be measured for multiple cities adapted to local contexts. That's why studies like this one in China have used this index for analyzing more than 328 cities. So fractional vegetation cover has been a valuable metric for diverse disciplines, essential for urban practitioners as it's simple and effective to translate the amount of vegetation across the city and also enables scalable and adaptable studies. So dive now into remote sensing world. One way of acquiring data at distance is through satellite that's in Earth orbit, so acquiring data for Earth observation purpose. In this picture, we see actually what it's commonly observed in Google Earth software that's more popularized, has a very high spatial resolution, is very good for validating and observing in time, as they also provide a time lapse, but they do not offer us the raw data acquired from the satellite, radiance, what we call radiance, and can be translated into values of reflectance, which actually bring us property from the land surface. So this is the same image for Sentinel-2. We see it's very coarse compared to Google Earth. However, we do have what I mentioned, the reflectance value, and this is very important. So Sentinel-2, as we see here in this graph, compared to other satellites that also provide data for free, such as Sentinel-2, detect the radiance in various parts of the solar spectrum. It's very important for vegetation, the visible spectrum, represented here in the numbers 2, 3, and 4, and also the near infrared, represented in number 8, which is roughly about 700 nanometers. While vegetation absorbs a lot of radiation in the red spectrum to make photosynthesis, in the near infrared spectrum, cell structure reflects a lot of radiation. Thus, by combining in a color composite the red and near infrared color, putting the green color to near infrared, we can see how much greener, how much brighter the vegetation appears in a scene, making easier to interpretation of a satellite image in urban areas, but also for other applications for classifying urban vegetation using machine learning algorithm and so on. And this relationship between the near infrared and red band is very well known in remote sensing since the 1970s. So the index called Normalized Difference Vegetation Index expressed this relationship between the difference and the sum of the near infrared and red bands. This relationship enhances vegetation information and in a scale that goes from -1 to 1, in which negative NDVI is usually represented by water bodies, while very close to zero NDVI are urban features that can be positive or negative, depending on the construction material. And bare soil usually has NDVI close to 0.2 or even lower, while vegetation has a range of NDVI from 0.3 to 1, depending on how photosynthetically active the vegetation is and how dense this vegetation area is. Although NDVI can represent the density of vegetation, its scale is not appropriate to express the fraction of vegetation within an area. To do so, some researchers explored the normalization of the NDVI by the maximum and minimum values, taking as maximum NDVI-S in very dense vegetated area and as minimum NDVI-O in non-vegetated areas. This relationship is also exponential. So comparing NDVI and fractional vegetation cover, we have even more enhancement of the contrast between vegetated and non-vegetated area. It's also important to note that the maximum and minimum NDVI-S and NDVI-O may not be necessarily the maximum and minimum in the scope of the scene. Therefore, it's important to manipulate the results in order to make FR equals 1 or 0 when NDVI is above NDVI-S or below NDVI-O. So in a nutshell, usually NDVI 0.25 is represented by very low or no vegetated areas. So fractional vegetation cover equals 0. For NDVI above 0.7, we usually have an area full covered with vegetation. So fractional vegetation cover is equal 1. And between 0.25 and 0.7, we have the interval in which we have an exponential relationship between NDVI and fractional vegetation cover. So let's compare now in this image how on the right, the fractional vegetation cover rather than NDVI in the center enhances much more where vegetation is located. You can see in this very compact building neighborhood that only where vegetation actually is, we have the greenness level. For forest cover, we approach the value, the calculated index to 1, as you see in this darker green color than for NDVI. And finally, for open build-up landscape, we can have also more contrast between vegetated and non-vegetated area, really increasing the value of pixels of where vegetation is really located. And those mixed pixels may have a lower value as compared to NDVI. So it becomes more conservative index as it actually shows where vegetation really is in a higher value. Well, that's it. Thank you a lot for watching, and watch the next video in which we're gonna show some example on how to calculate this fractional vegetation cover in Google Earth Engine. Thank you.